Okay, so we still have the standard form there. Y equals ax squared plus bx plus c. And the standard form there, do we notice that, guys? Do we recognize that? Does it look familiar? It's the same as the standard form of a quadratic equation, right? With a quadratic equation, it would just be equal to 0 as well. In this case, it's equal to y. Now, if they've given you the equation of a parabola in standard form, the c value is always the y-intercept, right? So the constant term there. The reason for that, guys, do you remember how do you calculate the y-intercept of any graph? By making x equal to 0. So if x is 0 in that term, the whole term is 0, and that one as well. So you will just be left with c. Okay, so that is the y-intercept. I've just done a little diagram here on the side. If a is positive, it's going to be an upwards facing parabola. If a is negative, it's going to be a downwards facing parabola. Alright, to find the x-intercept, you know this, I'm sure. You need to make y equal to 0 and then solve for x. So that will then be a quadratic equation. Alright, and then I think we did speak about this formula, the turning point formula, when we did this in AP. Right? If you have an equation written in standard form, you can calculate the x value. Sorry, I'm trying to just space that out. You can calculate the x value of the turning point by using this formula. Minus b over 2a. So b is the coefficient of the x term, and a is the coefficient of the x squared term. So you work that out, that will give you the x value of the turning point, and then to get the y coordinate, you need to sub that into the equation, which will then give you the y value of the turning point.
Your calculation should show you that anyway.
Yes. It's almost like a check. If you're getting points that don't satisfy that check, then you've done something wrong. Yes. Alright guys, are there any questions on this first form, on standard form? Anything that you want to just clarify? Anything that you want to ask? So basically, if they've given you standard form, you can read off the y-intercept straight away. That's the c value, and you can calculate the turning point. You can also calculate the x-intercept as well by making y equal to 0 and solving for x. Sorry. Okay, the next heading, if you want to write it down so long, underneath where I wrote standard form is turning point form. But I'm not trying to rush you guys, don't worry. Okay, I'm going to move down a little bit. Is that fine with everyone? Up until there. On the side here, you can't see it now, but it's turning point form. Okay, so if you want to write that there, turning point form. And then that is turning point form, which we have also discussed in AP. So it's a bracket x minus p squared plus q. Again, the a value here will tell you what shape you have. So if A is positive, you have an upwards facing parabola. If it's negative, it's a downwards facing parabola. And guys, if you take the same equation, or rather if you take the same parabola and you write it in the different forms, the A value in all the forms will be the same number. So if it's 2 in standard form, you will also have a 2 there for A in your turning point form. Right? And when we get to x-intercept, your A value will also be 2 there. Okay, so the A value is the same in the 3 forms. It doesn't change. Now what's nice about turning point form, and it's not very clear there, but I did actually highlight this P and the Q there. What's nice about turning point form is that you can read off what your turning point coordinates are from that equation. So if you have x minus p squared plus q, then p and q, those coordinates are going to be the coordinates of the turning point. Yeah.
I was wondering if you know the bias towards graphs that rather have more than one x value for each y value than the other way around. Because
What do you mean?
I mean, we always do function. It's not a function if there's multiple y values for the same x value. Do you know the reason for that?
No, I don't.
Is there practical application?
I have not studied in the right field to be answering that question, I think. Sure, I wonder. I think in terms of school maths, it's just that it's easier that they're all y equals, that you can write them with y equals, yeah. No, sorry, I don't know. Alright, y-intercept, same thing. Now, unfortunately, it's actually not the same thing, sorry. With standard form, you can just see what the y-intercept is, right? It's the c value. In turning point form, you're actually going to have to calculate the y-intercept by making x equal to 0. Okay, so you can see there, I've just rewritten that. Y is a bracket 0 minus p squared plus q. So you just use all the values that are given, you make x equal to 0. And that will then be your y-intercept. X-intercept, same thing, make y equal to 0 and then solve for x. And then you can read off what the turning point is from there. Any questions on turning point form? Alright, the next one, x-intercept form. That's what it says on the left there, x-intercept form. Just show you quickly. The turning point form, I can actually fit all of it in on the page like that. Is anyone still busy with the first stuff with standard form? Okay. So x-intercept form is not really a form that is commonly given in a question. So usually if they're asking you to draw a parabola, they will either give you standard form or turning point form. X-intercept form, this is more something that we use when we have to find the equation of a parabola. So what I have here is x1 and x2. And then the values of x1 and x2 are your x-intercepts. Did I even write that down anywhere? No, I didn't. Okay, so yeah, that is what you will get in the end there. Well, you would get the same answers, wouldn't you? Yeah. So if you forget that those are the x-intercepts, this is a method that you can always use. Okay, so guys, if you recognize that it is given in x-intercept form, but like I said, it usually isn't, you would have to factorize the equation that was given, and then it's an x-intercept form, right? But then you can just read off what those values are, because we know that if we have two brackets equal to 0, the values in those brackets will be our x values, right? Our solutions for x. So that is how that form works. You don't actually have to write this final step down. You can just kind of read the values off if you are able to do that. Now for this, unfortunately, there isn't a method to get the turning point straight from this form. You would have to multiply these brackets out and then use your minus b over 2a formula. Okay, or we can actually write it down somewhere. Guys, do we remember that the turning point is always halfway between your two x-intercepts? The x value of the turning point is halfway between the x-intercept values. All right, so we can maybe add that on the side, or if you still have space underneath, Let's write the turning point. Well, rather, let's say.
Is this still about the x-intercept form? Or is
Yeah.
this separate?
No, it's still about this one. X value of TP is halfway between x-intercept. So you don't actually have to use the x equals minus b over 2a formula there. If you have your two x-intercepts, you can just find the value that's halfway between them. So if your one x-intercept is at 0 and the other one is at 4, your x value of your turning point is going to be at 2. Okay, so just whatever those two values are, halfway between them.
You said that we don't use the minus b of 2a for the, doesn't have b.
Yeah, so you would first have to multiply out and then use minus b over 2a. Or you can use this.
Yeah,
that I just
or
wrote
just
down.
multiply out for all of them and then
Yes.
solve like that.
That's what the next note is about.
And then you just solve for. Oh, okay.
Right, any questions on x-intercept form? Alright, now something that is also new in grade 11 that we didn't really focus that much on in AP. In AP we were mostly just going on drawing the graphs, right? Because then we use that for absolute value graphs and so on. But in core it's quite important to be able to convert between the three forms. So for example, if they have given you an equation that's written in standard form, they can ask you to convert that to x-intercept form. Alright, so I've done some examples here as well. So the first type there, from standard form to x-intercept form. Guys, x-intercept form is just the factorized version of standard form. Right? Standard form is a trinomial. When you factorize a trinomial, you get those two brackets. That will give you your two x-intercepts. So if they are asking you to do that, you would simply have to factorize that trinomial. Or it might not always be a trinomial. In this case, it is a trinomial, but if you have something like x squared minus 4, that is still a quadratic equation, right? Or a quadratic function. A difference of two squares, you would also factorize and get your two brackets. Okay, so it doesn't have to be a trinomial, just a quadratic equation of some form that you would have to factorize. All right, the next one. Sorry, let me give you some more time there. It's always a Joel upstairs. We are furiously writing notes. They're bouncing a ball or something.
It sounds not like a Muslim.
I think they learned parameters.
Yes, they do.
They did what?
Parametisms. And lots of like financial stuff. They work with financial statements and tax and exactly. Yeah. I don't even know. I go on to e-filing. I'm like, oh. Alright, the second one there, point B, if you're going from x-intercept form to standard form, you just have to multiply the brackets out. Okay, so I've done an example there where we have an a value that's 2, and then we have our two brackets. I'm sure you guys are all fine with multiplying those out. Then you would just have to simplify, obviously, to get your standard form in the end. Right. Are we all done with A? And move up. Alright, for C, this is now the more difficult part. If you are going from standard form to turning point form, okay, there's quite a lot on the side there. I think maybe just write down the steps first or the working first, and then you can fit in the steps on the side. I'll have to move across for that. So for this, you have to complete the square if you're going from standard form to turning point form. Guys, do you remember when we did analytical geometry, the circle stuff? Do you remember that circles chapter that we did? In those questions, often you were given an equation in, it was also called standard form, and then you had to write it in center radius equation form by completing the square for x and for y. It's the same method that we're using here. Alright, so completing the square, it was given in standard form. The first thing that you would have to do in this case, sorry, let me zoom in a little bit. In this case, we have an a value of 2, so you have to take that a value out. Guys, even if it's not a common factor, okay, sometimes, say for example, that 12 was an 11, you would still have to take out the 2. Okay, you always have to take out the a value, regardless of whether it's a common factor. So sometimes you can be left with a fraction in that second bracket. Alright, the next step then, if you're looking at your bracket that you have, you need to identify the b value, which is 5 in this case. And then you're going to add b over 2 squared, right? Do you remember that from completing the square? You add b over 2 squared, but now we can't just add something, right? We actually have to then negate that addition by subtracting it again, which is a bit strange, right? We are adding 5 over 2 squared, and then we're subtracting 5 over 2 squared straight away as well. We are doing that because this is actually equal to 0. Right, so if we're adding it and we're subtracting it, we actually haven't changed the value of this expression, this equation that we have. But we are creating a perfect square trinomial, essentially, by adding that 5 over 2 squared. And then we need to subtract it as well. So what I've done here is I'm showing the plus 5 over 2 squared and then the minus 5 over 2 squared. And remember, we still had that 6, which was there originally. We need to write that again. From the next step, your first 3 terms here in your square bracket now. And guys, the only reason why I introduced square brackets was because I was going to have these round brackets already for the 5 over 2. You are now going to basically factorize those 3 terms into your bracket squared. Right? So remember, you always take the square root of the first term, the square root of the last term, and then that first sign. The sign of your middle term goes into those brackets. And then these numbers here, these values, you need to simplify. I've highlighted them. So minus 5 over 2 squared plus 6, when you work that out, will give you negative 1/4. That is not fully, turning point form yet. We still have a 2 here in front of the whole square bracket that we then need to multiply back into those brackets. So 2 multiplied by the brackets, and then 2 times negative 1/4 is negative 1/2. Right, once you've done all of that, that is turning point form, and you can then read off the value of your turning point, the coordinates rather, of your turning point. Guys, I suggest that you only do this if they ask you to. Alright, if they've given you an equation in standard form, and you want to find the turning point, I've seen it many times before. People get given this equation, they're like, oh, I need to find the turning point, so I must write it in turning point form. So they go through all of this hassle to get to this, and they make a mistake somewhere along the line, and they get the wrong turning point anyway. Remember that you can use minus b over 2a to find the x value of your turning point. Okay, so only do this if they've asked you in the question. Convert this equation to turning point form.
Could you also just do get the halfway point to the x and center?
Mm-hmm. What do you mean for this type of question?
Or more, I mean, if they say give us a turning point, instead of doing all this, you can just go.
Yes, you can use whatever. Yeah, you can use whatever other method there is. Yeah.
So they will specifically say we want you to give it in turning point 4 or x and 4 or standard form.
Yeah. And if they don't say anything, we assume it's standard form.
So if we give it an accent and they didn't say anything, that's wrong.
All right, can I move across so that you guys can see the steps here? Are you still busy? Okay, I'll give you a little bit more time.
Do you think we're going to be ready in time to cover it?
Absolutely.
No.
I'm excited for the dress rehearsal. Yes?
Could you show how? Okay, so I get you understood. Add subtraction. Normally, you do the subtraction of the VO2 squared on the other side.
Yeah, if it's an equation.
Is essentially you've added to the other side, and now moving it back over. Yes.
Because now you have
Okay, so if you didn't move back over, where would it go? Where does it go originally?
Suppose
In the
it
bracket.
couldn't go anywhere else because you have, it's not equal to 0. Yeah, it's in the bracket.
might as well continue.
If it wasn't in a bracket, I suppose you could have y plus 5 over 2 squared
Yes,
on the other side, but you would then have to move it across anyway because you have to group it with that 6.
I get that you would do it, but I was more curious as to where it would go when it's in brackets. So it cannot go out of those brackets.
Alright, can I move over to those steps on the side?
Yeah, and then.
Right, there we go.
Go into B at some point. And then
I just want to finish D and then I'll go.
Yeah.
Show you the rest.
So don't do this. Yes, okay. Sorry, I was trying to do. You were trying to do it without taking the A. I was trying to do perfect stretching. Which is possible, but gross.
why is there two?
During the second half.
Ma'am, is that
From
the
the.
bracket squared, or is that saying there is a second bracket?
Why not? Put the first 3 terms into a bracket squared.
No, but would it not be you put the first 3 terms in, and then you factorize it, and you get a square?
When you factorize it, it is a bracket squared, yes. So you can write it in whichever words you want to use there. I think we're saying the same thing, right?
So we're going to, on the night, we're going to do both. So what we've done in 2 days is going to happen in one night.
Because presumably there isn't going to be any of this. Where's this person? All these people. Change this, change this.
Do you know how long?
We're going to time it when we do our first proper run. Alright. Can I move on to D? Almost.
Sorry, man, last thing. Also, our Max is really jazzed because we want to take care of actually play.
Yeah. What do you mean?
Are you gonna like come to the music block?
No, I don't know. What do you need that's in there that you can't have
We
with
need
you?
an electrical and amps.
And you can't bring it to the hall?
I guess
Is
we
it too
could
much
do
of a
that.
mission?
But
I mean, we do have... Are you going to be on the stage?
no, we're gonna be like next to the ground.
Yeah, we do have to also, like, look at the spacing, but I don't know
Because that bit,
if the
that
piano
was,
is where it's going to be.
I think that's where the halftime show was gonna be. Because they were gonna use the ground.
Not sure. We haven't actually discussed exactly how we're going to do
I
that.
think that's what Mr. Ford does.
Alright, D. From turning point form to standard form. Again, very easy. We're just going to multiply out the brackets. Yeah, B is very similar. It was x-intercept to standard form. This is turning point to standard form.
Are we only doing parabolas or are we not doing the hyperbole?
No, we're doing all of them.
You know how to go from x into turning points.
You would just do one extra step in terms of multiplying out and then do the completing the square. Yeah. So it's almost a combination of two of them.
Okay.
What are you saying now?
Is this not like, is the second step not already the accepted words?
What? The second step?
Yeah, the second line, is that not already accepted?
No, because there's a -9.
The minus 9.
X-intercept form has to be 2 brackets equal to 0. Or not equal to 0, just equal to y, I mean.
Why would that?
Because I think what Mr. Goodman said is he thought that we could maybe just go to, you could maybe go to tuition.
Maybe. I don't know, we haven't discussed it as the teachers, so we might do that, yeah.
Yeah, correct.
2 had some debt, so we had to.
1.2 is not.
Alright guys, any questions on these different forms?
It's correct.
It's so far from not that normal stuff.
Normal stuff. He's looking at normal.
For now, sorry, I just want us to practice going from the different forms. Just for now, we might start the next note as well in this lesson still. We'll see how you guys go. Sorry, I'm just quickly moving things around so that it fits on the board.
Because we do that classwork homework thing.
Yes, I'm just quickly moving it so that it fits on the screen. Alright, so you can just write classwork. You don't have to write classwork / homework, whatever. And I'm going to put the questions on the board for you.